Our next objective is to learn how to prove identities. And when we prove identities, we use the fundamental identities to help us complete the proofs. So let's review the fundamental identities to start with. And then in this section, we're just going to practice using these identities, but we're not going to write any proofs. In the next section, we will actually write some proofs. And of course, we'll talk more about that when we're ready for it. So let's review. These identities are ones that we've already discussed. So I'm not going to prove them again, but we're just going to list them here. So the reciprocal identities, of course, are that sine x equals 1 over the cosecant of x, and the cosecant of x is 1 over the sine of x. The cosine of x is 1 over the secant of x, and the secant of x is 1 over the cosine of x. And then the tangent of x is 1 over the cotangent of x. And cotangent x is 1 over tangent x. And I think we're all pretty used to using those. We use those a lot. The tangent-cotangent identities just say that the tangent of x is equal to the sine of x over the cosine of x, and the cotangent of x equals the cosine of x over the sine of x. And of course, those are ones we've been using a lot as well. When we initially gave these, we did it in terms of an angle, but notice I'm using x for real numbers now. And of course, we could replace that with Greek letters to represent angles as well. The Pythagorean identities, the first one that everybody should remember easily, sine squared x plus cosine squared x equals 1. Right, there's 3 of these. The second one, again, the second and third ones are a little harder to remember, but if you go through and divide by sine squared x and then again by cosine squared x, you'll pick up the other 2 identities. So let's do cosine squared x first. So sine squared x over cosine squared x would be tangent squared x. And then cosine squared x over itself is 1. And 1 over cosine squared x would be secant squared x. And then you'll get the correct identity. Remember where the 1 goes in the other functions, if you have a hard time remembering those. All right, and the other one then we pick up if we divide by sine squared x. So of course sine squared x over itself is 1. Cosine squared x over sine squared x is cotangent squared x. And then 1 over sine squared x is cosecant squared x. The cofunction identities, that the cosine of pi over 2 minus x equals the sine of x, and the sine of pi over 2 minus x equals the cosine of x. So sine and cosine are cofunctions. Secant and cosecant are cofunctions. So secant of pi over 2 minus x equals the cosecant of x. Cosecant, not cosine. Cosecant of pi over 2 minus x equals the secant of x. And then tangent and cotangent are cofunctions. So tangent of pi over 2 minus x equals cotangent x. And cotangent of pi over 2 minus x equals tangent of x. And then, just for completion, let's review the even-odd identities. So recall that sine is an odd function, so sine of negative x equals negative sine x, and therefore cosecant is as well. It's reciprocal. Whoops, there should be a negative in front of there. Cosine is an even function, so cosine of negative x equals cosine x. And so then secant is as well. And then tangent is odd again, like sine. So tangent negative x is negative tangent x. Again, we proved these. I can't remember which section it was, but if you need to review, go back and review that section. Cotangent negative x is negative cotangent x. All right, so let's do some problems. We're just going to simplify expressions. In this example, this first example here, we're going to use or find the values of the trig functions given cosecant of x is -4 and cotangent is positive. Now you can certainly use a triangle in the xy plane to do this problem, but we're going to do it using identities. So we still need to know which quadrant x is in to complete the problem, so we know the signs of all the functions. Since we know cosecant, we would know sine because those are reciprocals, so we don't even need this for sine. Cosecant of x is -4 would imply that the sine of x is -1/4, the reciprocal. So then we need a function, or an identity that relates one of these functions with another function. So if you go to the Pythagorean identities, those would be the best choice. So we can use the first one if we want to use sine, and we can use the third one if we want to use the cosecant. So I'll just go ahead and use the sine. Sine squared x plus cosine squared x equals 1. Replacing sine of x with a -1/4. So remember, sine squared x is the sine of x squared, so it's -1/4 squared. Plus, so let me write down what I said, because when you say it, it's still not clear. It means this, right? Not this. Whoops, I think I'm writing off screen. Let me push this down. So sine squared x equals the sine of x squared, that result squared, not this. This would mean square x and then take the sine. So these two are equal. So sine of x is -1/4, that is the number that gets squared, plus cosine squared x equals 1. Let me put my paper back. All right, so -1/4 squared is 1/16. So cosine squared x is 1 minus 1/16. Remember, 1 is 16/16, so you need a common denominator, right? So this is 15/16. So let me write this down again. Cosine squared x is 15/16. We're going to take the square root of both sides. And here's where this helps, because we know sine and cosecant are negative. So that means we're in quadrant, using this, well, even just one or the other. We know we're in quadrants 3 or 4. But because cotangent is positive, then we know we're in quadrant 3 and not 4. Remember, tangent alternates, right? So it's positive in the first and the third. So cosine is negative in quadrant 3, so cosine of x is negative square root of 15/16. So cosine of x is negative square root of 15/4. You should reduce the perfect square under the radical. And then once we have that, I used up a lot of my room there, we can find the other 3 functions. Right? We've got this one, and this one, that's 3. So then tangent, well, let's do secant first because that's just the reciprocal of this. So secant of x is -4 over square root of 15. And you don't have to rationalize that, but if you do, -4 square root of 15/15. And then tangent of x will be the sine over the cosine. So -1/4 over negative square root of 15/4. So when you divide by this fraction, you're multiplying by the reciprocal. And what will happen, I'll put this in here, the shortcut is you're just going to end up canceling these denominators, right? So negative 1/4 times negative 4 over square root of 15, cancel, cancel, the negatives cancel, and you just get 1 over the square root of 15. So if these denominators are the same, they simply just cancel. That makes it easy. You just get 1 over square root of 15, or square root of 15 over 15, again if you rationalize. And then cotangent of x is the reciprocal. So when you're flipping that, I would flip this form because then it will already be rationalized, square root of 15. And then double check that this does agree with what we were given. Cotangent of x is positive, which of course means tangent of x is also positive. So there's our other 3 answers. So 5 answers you had to give since we were already given 1 in the problem. And when I do this, I always write my variable down. If on the test, if you write just cotangent equals square root of 15, tangent equals 1 over square root of 15, I'll take a point off for that because you have to have an input into the function. It doesn't make any sense to just write the function name without the input. That would be like, writing square root equals 4 with no input. You have to have the input. So the variable stands for the input in these, and I'll be picky about that. So make sure you're writing down the variables. Or the numbers if you know the number. Okay, so let's go ahead and go on to the next example. We want to simplify. So, hold on a second. Did you hear my dog? I'm going to pause the video in just a second. Sorry.